Hey guys! So, the last time that we talked, you guys made your own hypothesis about whether you thought light has to be closer to an object or farther away in order to make a short shadow. And then we also talked about would the light have to be close or far away to make a big shadow? Because if you've ever been walking around outside or sometime when you've seen your shadow, we know that the sizes of those shadows can change depending on how close or how far away the sun is or whatever our form of light is. So when we go back to our standard, we're thinking about how these shadows are affected based on where the sun is and how it's moving. So our hypothesis question, again yesterday, do we think that light has to be closer to an object or farther away in order to make a small size shadow, and then vice versa for a longer shadow? And we're getting ready to test that out. So we talked about yesterday how a hypothesis is an educated guess. It means that we don't really know the actual answer yet, but number one, we're going to test it. And number two, when we say our hypothesis, we are using information we already know. Now, this may be scientific information that we learned at school or saw in a science book, but it can also be just knowledge that you already know about the world, about anything, to form your hypothesis. So we did that yesterday, and you guys submitted those to me. And I was just going to share with you my hypothesis. Number one, I want you to be able to see kind of how I worded my hypothesis, how I set it up, how I made my thought really clear, and that I used because anytime you say you think something, you should always be able to follow up with because. I think this because, and then that's where you're showing me the educated part of your guess. So I'm going to show you my hypothesis. I really was torn here. I wasn't super sure. I know a lot about the planets, but I didn't really know a lot about shadows. So I just kind of had to make that guess based off of some things I might already know. So I'm going to read it to you, and then I'm going to flip off the lights and we're going to test it, because that's what you guys have already done. And you guys probably watching now already know the answer to our scientific question, but I'm getting ready to find it out live, real time with you right now. So my hypothesis, so I started out by saying I believe, because I'm kind of restating the question, the scientific question we're trying to answer, I believe that a short shadow is created when the light is closer to the object, because the closer it is, the more blocked it becomes by the object. Now, this is not a lot of scientific knowledge down here. This is just me just thinking through a light getting close to something. And I was just thinking that maybe when the light gets really, really close, it gets up behind that object to where the shadow's not going to be a lot. But like I said, I really wasn't sure. So I think it could be either one, but if I had to pick one, I just said that based off of just my reasoning of what I thought about space, distance, and objects that I kind of already knew. So we're going to test it out. And the first thing that I'm going to do is I'm going to test it out with just my hands, because I told you this is something really fun to do, especially since we're all at home, something that you can do with your brothers and sisters or someone in your house. You can do shadow puppets. You can kind of see one right now, but I'm getting ready to turn the lights off so that we can really see what it's like, and we're going to test it out. So remember, I said that the light needs to be closer to the object to make a short shadow. So I'm going to test that first and just see what happens. All right, so I'm going to start by putting my hand up here. You can see my shadow. Now, when I bring my shadow, my light source close, you can see my shadow kind of grow. But when oh, okay. See, when I held that up there, I thought that's not a very big shadow. But when I pull it back, I'm starting to see that my shadow gets a lot smaller. So I'm starting to see that maybe my hypothesis, even though I did think through it, I'm thinking that my conclusion is going to be that the light actually needs to be farther away to make a shorter shadow. And when I bring the light really close, wow, look how big that is. When I bring the light really, really close, I get a much bigger shadow. So when I pull it apart, I get a lot shorter, smaller shadow. When I bring it in, it gets a lot bigger. Okay, so since we've tested that, I do want to show you one cool thing. I'm going to flip the light on for 1 second. So in the dollar spot at Target, if you're ever there with your mom and dad, and this is something they would want to get for you, these are $1 at our dollar spot in Target. And these are actually shadow cards. And I thought these were really, really cool. So I'm going to show you how they work. So this is one of them. It's got a little adventure logo. When I turn the lights off, and I shine my light on it, there we go. You can see the picture a lot bigger there. So I actually could test with this as well. Look how big it gets when I put my light towards it, and look how small it gets when I bring my light source out. And remember, I want you to think about your flashlight or whatever light source you're using as the sun, because the sun is moving and it's at different distances at different times, and that does affect shadow size, which is what our standard wanted us to learn and see. So I'm going to flip my lights back on. Woo, that got really dark for just a second. Sorry, guys. All right, so my hypothesis, I would have to go back and change, or not, I wouldn't change my hypothesis, but when I went to write my conclusion, I would have to say that the closer the object is, the bigger the shadow, instead of what I said. And I think it's really important that we know that our hypothesis is not always right, and that does not mean that we did something wrong or we're wrong. One reason that scientists have all this work to do in science, no matter what the topic is because we don't know a lot of things. And the only way to find out is to use what we know to get us started towards testing out a theory, our hypothesis. If we never had a way to start, we would have a really hard time getting something together to even test. So it's a really big deal to put some thought into your hypothesis and not be discouraged if it's not exactly what you thought it was, because in the end, what happened was we learned something. So I hope that you guys learned something from your hypothesis today. I hope that you were able to test out your hypothesis and see what you were able to find out. I don't want to say right or wrong, what you were able to discover about shadows. And again, just one more time, I want you to remember that our solar system is huge. We live on the planet Earth, but Earth is not the only planet in our solar system. There are so many planets, so many galaxies, so many stars. We are just a small part of our galaxy. And that's actually another one of our science standards that we're supposed to know, is that it's not just us. And it's super important for us to know that there's a vast galaxy out there that a lot of it, we don't even know what's out there, which is really exciting. And probably in you guys' lifetime, we're going to learn more and build machines that can go further into space than they can right now. So those are just a few things to keep in mind about space. And after you're done watching this video, you are going to watch the Dr. Banach video on shadows, and hopefully just wrap up this information about shadows. I thought he gave some really good examples of how shadows work, and I think you want to watch that now that we've done our complete experiment. I actually waited until I was done because I didn't want to know the answer to our hypothesis, but he actually does test that out in his video too for you to see and gives you some other information. So I hope you guys enjoyed our science lesson for this week, and we'll see you next week.